Hi everybody, welcome to my channel again. This is Oliver. We are learning algebra by working through many problems from the Larson textbook. This is section 2.1. We're going to do a review for mastery problems today, as well as challenge practice problems. The goal in this section 2.1 is to graph and compare positive and negative numbers. The main concepts are whole numbers, integers, rational numbers, opposites, absolute values, conditional statements. We discussed those in previous videos, so I'm gonna skip and go start solving problems. So scroll down again. All right, so the first problem, graph the numbers on a number line. We have 0, right? And we have the positive numbers to the right and the negative numbers to the left. We have to plot -4 and -2, so we know that those two are on the left side of the 0. And let's count, so -1, -2, -3, -4. So -2 would be right there, and then -4 would be right there. So we graph the numbers on a number line, then tell which number is greater. -2 is greater because -2 is greater than -4, because -2 is to the right of -4. So as you're moving to the right, the numbers increase, right? Next one, number 2, 0 and -3. So we have 0 and -3, -1, -2, -3. So -3 would be right there, and 0. Which number is greater? 0, right? 0 is greater than -3 because 0 is to the right of -3. Number 3, we have 1 and -1. So 1 is greater than -1 because it's to the right of -1. Okay. Let's look at now 4, 5, 6, and 7. Okay, let's look at 4, 5, 6, and 7. Tell whether each number in the list is a whole number, integer, or rational number. Okay, so let's start with number 4 first. I'm gonna, here to the left, I'm gonna write whole numbers, integers, rational numbers. Okay, this is number 4. So 2, we know that whole numbers start from 0 and go 1, 2, 3 all the way to infinity. Those are the whole numbers. Integers start from -infinity all the way to -3, -2, -1, 0, 1, 2, 3, all the way to plus infinity. And then rational numbers are represented by a quotient of 2 integers. For example, 2 integers. So let's pick -3 and 1, -3 and 1, or can be 5 and 2, or can be 3, because 3 is 3 over 1. So whole numbers, we can say 2, yes, 2 is a whole number. 1.5 is not, -3 is not, -0.5 is not. Integers, 2, yes, 1.5, no, -3, yes, -0.5, no. Rational numbers, 2, 1.5, -3, -0.5. And then order the numbers from least to greatest, okay? So we have negative numbers, so those are going to be listed first. So which one is least? -3 is to the left of -0.5, so -3 comes first, and then -0.5, and then 1.5 is smaller than 2, right? And 2 is the largest of these 4 numbers. Let's do number 5 now. So whole numbers, integers, rational numbers. 0, yes, it is a whole number. -0.3, no. -0.6, no. -0.1, no. Integers, 0, yes. -0.3, no. -0.6, no. -0.1, no. Rational numbers, all 4. 0, -0.3, -0.6, -0.1. And then order the numbers from least to greatest. So we have negative numbers. Minus 0.6 is the one all the way to the left, so minus 0.6. Then the second number from the left is minus 0.3. So remember how you are plotting these on a number line, and you're just ordering them from left to right. So minus 0.6, then minus 0.3, then minus 0.1, and then 0. Number 6, we have whole numbers, we have integers and rational numbers. First one is minus 3.2. Whole numbers, no, that's not a whole number. 1, yes. 2.5, no. Minus 1/2, no. Integers, minus 3.2, no. 1, yes. 2.5, no. Minus 1.5, no. Rational numbers, all 4. Minus 3.2, 1, 2.5, and minus 1/2. Then order the numbers from least to greatest. We have 2 negative numbers. We're gonna plot those, right? We're gonna list those first. Minus 1/2 is minus 0.5. So this one is all the way to the left on the number line. So we're gonna do minus 3.2. Then this one, minus 1/2. And then 1 comes next, right? So 1 and then 2.5. Okay. Number 7. Let's start with, again, we're gonna whole numbers, integers, and rational numbers. Whole numbers, we don't have any whole numbers, so just say none. No whole numbers. Integers, we don't have integers, so none. Rational, all 4. So 1/5, minus 2/3, 2/5, minus 1 and 1/2. Minus 1 whole and 1/2. Okay. 8, 9, and 10. For the given value of a, find minus a and absolute value of a. Okay, so we find the opposite of a, so minus a, and then absolute value of a. Okay, and a is 5. So we just plug in 5 for a in both cases. So minus a becomes minus, instead of a, we have 5. So this becomes minus 5. Absolute value of a becomes absolute value of a. Instead of a, we plug in 5. So absolute value of 5 is 5. And we know that absolute value of positive or negative numbers is a positive number. Number 9, minus a and absolute value of a. So this is minus, instead of a, we plug in this. So minus 11, right? So minus, and then instead of a, we plug in minus 11. So minus 11 in parentheses, now we have minus and minus. We know that minus and minus equals plus. So this is 11. Absolute value of a, absolute value of a is minus 11. And we know that absolute values of positive or negative numbers is a positive number. So this is 11. Number 10, minus a and absolute value of a. So minus, and then instead of a, we substitute this value, minus 3.91. And we know minus and minus equals plus. So this is 3.91. And now absolute value of minus 3.91, which is 3.91. Okay. Challenge practice problems. Order x plus 3, and x minus 2 on a number line. Does the order change depending on whether x is positive or negative? Okay. So let's say this is the number line. X, let's say x is 0, right? If x is 0, then the first number is going to be here. Then x plus 3 would be 1, 2, 3. So x plus 3 would be right here. This would be x plus 3. This is x, and then x minus 2 is 1, 2. So this is x minus 2. Okay. So if x is 0, this is what we have. If x is 1, 1 plus 3 would be 4. So if we move x 1 to the right, now x is positive number, x is 1, this x1 plus 3 is 4, so this moves also 1 to the right. x1 minus 2 is minus 1, so this also moves 1 to the right. Now, if x is minus 1, so x moves 1 to the left, 1 unit to the left. Minus 1 plus 3 is plus 2. This one moves 1 to the left as well. And then minus 1 minus 2 is minus 3. This one also going to move 1 to the left. So it doesn't matter. The order doesn't matter whether x is positive or negative. So does not matter. Okay. In exercises 2 to 5, evaluate the expression when x equals minus 1. So let's say x is minus 1, and we're going to divide these here, and then x is 0, and then x is 1. Okay. Evaluate the expression when x is minus 1, 0, and 1. Then determine whether the result is a whole number, integer, or rational number. So we have to solve these for these three values, and then the result we say, is it whole number, integer, or rational number? So x squared, x is minus 1. So minus 1 squared. So minus 1 squared plus 1 over minus 1 and minus 3. Minus 1 squared is minus 1 times minus 1. So when we multiply minus and minus, that becomes plus. 1 times 1 is 1. So this is 1 plus 1 over minus 1 and minus 3. This is the same as you owe someone $1 and someone else $3. You owe $4 altogether. So this is, you are adding up two negative signs. Minus 1 and minus 3 is minus 4. So 1 plus 1 is 2. 2 over minus 4, or that is minus 1/2. So minus 1/2 is the answer. Is that a whole number? No. Is that an integer? No. Is that a rational number? Yes. So this is a rational number. Rational number. Okay. When x is 0, we have 0 squared, that 0 times 0 is 0, right? So that's 0 plus 1 over x is 0, so 0 minus 3. 0 plus 1 is 1. 0 minus 3 is minus 3, so this is minus 1/3. Okay. And is that a whole number? No. Integer? No. Rational number. So this is a rational number as well. When x is 1, 1 squared, that's 1 times 1, which is 1. So 1 plus 1, 1 and plus 1 over 1 for x, so 1 minus 3. 1 plus 1 is 2. 1 minus 3 is minus 2. Or this is minus 1, right? The negative sign, and 2 over 2 is 1. So minus 1. Is that a whole number? No, not a whole number. Is it an integer? Yes, it is an integer. But is it also a rational number? Yes. So it's an integer as well as a rational number. Number 3, when x is minus 1, we have minus 1 over minus 1 squared, that's minus 1 times minus 1, which is 1. So 1 minus 2. 1 minus 2, that's minus 1 over 1 minus 2 is minus 1. So minus 1 over minus 1 is just 1. Okay. So is this a whole number? Yes. Is this an integer? Yes. Is this a rational number? Yes. Okay. When x is 0, we have 0 over, and then 0 over any number is 0, right? So this is a whole number. It is an integer, and it's a rational number. Okay. When x is 1, we have 1 over, and then 1 squared is 1 times 1, 1 minus 2, 1 minus 2. This is 1 over, 1 minus 2 is minus 1, so this is minus 1. Is a whole number? No. Is it an integer? Yes, it is an integer. It's an integer, and then it is a rational number as well. number 4, when x is minus 1, you have 1 minus, and then it's, for x we're substituting minus 1 over, this is minus 1 squared plus 1, so 1, and then minus and minus is plus, so this is plus 1 over minus 1 squared is minus 1 times minus 1, or just 1, so 1 plus 1, so we have 1 plus 1 over 1 plus 1, that's 2 over 2, or just 1. So this is a whole number, it's also integer, and it's rational number. When x is 0, we have 1 minus 0, which is 1, and then 0 squared is 0, plus 1 is 1, so this is 1 over 1 or 1. This is again whole number, integer, rational number. When x is 1, we have 1 minus 1, which is 0, and then 1 squared is 1 plus 1 is 2, so 0 over 2, which is 0. And so that's a whole number, it's an integer, and it's a rational number. And number 5, x equals minus 1, so minus 1 squared plus 2 over minus 1 cubed plus 2. Minus 1 squared, that's minus 1 times minus 1, which is 1, plus 2 is 3. Minus 1 cubed, that's minus 1 times minus 1 times minus 1. There are 3 negatives, so that's negative. We're going to end up with a negative sign, and then 1, and then plus 2. So it's the same as minus, let's write it down here. So minus 1 times minus 1 times minus 1. So minus 1 times minus 1, that's 1. And then times this minus 1, positive and a negative sign is negative. 1 times 1 is 1. So that's why it's negative 1. Okay. Plus 2 equals, this is 3 over minus 1 plus 2 is 1. Or this is just 3. So this is everything. Whole number, it's an integer, and it's a rational number. When x is 0, 0 squared is 0, plus 2 is just 2. 0 cubed is 0, plus 2 is 2. 2 over 2 is just 1. So this is everything. Whole number, integer, rational number. When x is 1, we have 1 squared, that's 1, plus 2 is 3. 1 cubed is 1. That's 1 times 1 times 1. 1 cubed is 1, plus 2 is 3. 3 over 3 is 1. This is, again, whole, integer, and rational number. What is the opposite of the opposite of the opposite of A? Okay, so the opposite of A is minus A. Opposite of minus A is A. Opposite of A is minus A. So minus A is the answer. Tell whether the statement is true or false. If it is false, give a counterexample. The sum of two non-integer, okay, the sum of two rational numbers, but non-integer, okay, so this is something like, so rational numbers, we know that is a quotient of two integers. So if it's something like 4 over 2, that's 2, so that's an integer. So non-integer would be something like 1/2 or 3/4, right? So when you sum two non-integers, so you're summing something like this, right, where the numerator is smaller than the denominator. So let's say 1/2. The sum of two non-integer rational numbers, okay, always results in a non-integer rational number. This is false. This is false. Why? Because 1/2 plus 1/2 right here, this is half and half, this is whole, or just 1. And 1 is an integer. And it's here it says it's always a non-integer. That's a false. Okay, and this is the counterexample right here. The division of two whole numbers always results in a non-integer. Okay, the division of two whole numbers. So whole numbers we know are 0, 1, 2, 3, all the way to plus infinity. When you're dividing two whole numbers, I don't know, let's say 4 and 2, right? Or it can be 1 and 2. I don't know. Okay, always results in a non-integer, okay? 1/2 is a non-integer, but 4/2 is 2. That's an integer, right? So this is false. This is false as well. Why? Because when we're dividing two whole numbers, 4 and 2, right? 1, 2, 3, 4, 5, right? We're dividing 4 and 2, and 4 divided by 2 is 2, and 2 is an integer. Here it says it always results in a non-integer. This is false. This is the counterexample right here. Number 9, the product of, we are multiplying, right? The product of a non-integer rational number, okay? So something like this, right? 1/2 or 3/4. So let's say 1/2. The product of a non-integer rational number and a whole number, okay? So whole numbers, you know, any one, let's say 4, okay? And a whole number always results in a non-integer. Well, 1/2 times 4, that's 1 times 4 is 4, divided by 2 is 2. So this is 2, and this is an integer. So this is false, false again. Because it says always results in a non-integer, but this is integer. So this is the counterexample. This is false, okay? Number 10, the square. So there is something and we are squaring it. The square of a non-integer rational number. So something like 1/2 or 3/4. So let's do 1/2. The square of a non-integer rational number is always a non-integer rational number. Okay, so this is 1/2 times 1/2. 1 times 1 is 1, 2 times 2 is 4. So is always a non-integer rational number. This is true. So let's try some other ones. So the main point is this has to be a non-integer. So this has to be a fraction where the numerator is smaller than the denominator. It has to be something like 1/4 or 3/5. So it's always, the numerator is always going to be smaller than the denominator, and when you're multiplying that number with itself, it's always going to be a fraction again, and it's always going to be a non-integer. So this is true. Okay, so this is, again, this is going to be 1/16. So that's all for today. Please like, share, and subscribe to see more videos. Thank you guys. See you next time. Bye bye.